All right, so properties of powers and fractional exponents. Yesterday, are you guys okay with the properties of powers?
Yeah.
Okay, usually I find that's the case, I just want to make sure. It gives us a chance to do something a little different yesterday too, which is always fun. Okay, fractional exponents.
There's someone waiting outside. Separate so outside.
That's right. No, not at all.
He did, we had to remind him.
No. I'm like, okay, I'll just sit out and use the whole hour. I'm cool with that.
I bet you are, yep, about that.
Totally gonna forget the whole bus ride. We didn't say anything.
I've done that before. I've let people sit out there for like 20 minutes.
That's
So usually shut the door,
You don't hear
so you can't hear it. Okay. The fractional exponents, you'll see those as roots, like square roots and cube roots and fourth roots. Okay. You'll also see them as exponents, okay, and we're going to combine the two of them. So we'll have an exponent and a root together. And I'll kind of give you some strategies to solve those in your brains. But most of the time, these are a calculator exercise. Okay. So first of all, let's say we talked about this yesterday. What fractional exponent was the square root? Anybody remember? Yeah, because this is a square root, right? So if I write a cube root, what fraction would that be? Yeah. So those, you see the match. The denominator is the root, correct? That's kind of the big idea with the root. We use this a ton next year. So we're just kind of preparing you for that. This is 4, anybody know what that is? This is one I would suggest memorizing. 8. No, that's the square root of 64. Some number cubed is 64. Yeah, it's 4. So there's the relationship. 4 cubed is 64. The cube root of 64 is 4. Those are called inverses. We've studied inverses quite a bit this year, right? We could also say that square root of 16 is 4, so 4 squared is 16, right? Inverse relationships are very important in math, so it's a good thing if you can understand those. We can use these in the properties of powers. This is a simple, do you understand the fourth root and properties of powers here? Remember, so this would be C, right? You multiply, because it's exponent to an exponent. Anybody know what 81 to the 1/4 power, or the fourth root of 84 is? 3. Yes. Because 3 to the 4th power is 81. So it'll make your life a lot easier. It's made my life a lot easier because I'm a math teacher. But if you, many of you know the squares, right? 2 squared, 3 squared, 4 squared, 5 squared. You're pretty good there. If you memorize opposed? Sometimes the answers come easier too. 2 cubed is 8. 7. 64 and not a requirement. Not going to test you on it. A suggestion, and you can always calculate them out anyways, but just they're good ones to know. Anybody know what 6 cubed is?
It's definitely a number.
16. Is that right?
That one pops up once in a while. Yeah. I mean, oh, what? Yeah, very nice.
Yeah, found.
No.
Did you take minutes?
No. Busy.
No
Yeah,
need to change it.
Yes, ma'am.
Just that
Yeah, Bailey, Rao, Taylor Mills, Evan Hall, Danielle Call.
That's it.
I think that's it. Yep. Hey, bye.
That's not it.
Well, tennis is taken.
How often do you actually have to use that?
About once every, oh, you mean,
How often do you actually like take attendance?
I take it every day.
You sure?
Yes. It tells me if I don't. If I forget first hour, I go to second hour, it tells me I haven't done first hour yet. So, there you go. What? Not what I wanted to do. How would I simplify that expression?
That would be,
9 to the 1/6 and x to the 3/6.
So you can write it as an exponent, right? Now 3/6 simplifies, right? 1/2. Can I simplify that?
It's not a fun number. So what is this?
Why don't you try to make it like
Is there an exponent for 9?
Uh,
3 squared, right?
Yeah.
So we can rewrite it as such. And now we can simplify 2 times 1/6 is 1/3, right? That could be your final answer. I'm okay with that. I don't know what the back of the book actually has. Probably this. This is probably your book answer.
Well, sometimes it like.
I'm okay with this. The book answer is probably in roots because it begins in roots, right?
Yeah, sometimes it comes in pretty radical.
And sometimes, but again, I'm okay with this. All right, so take your pick there. Just a quick note.
Wait, why did you get 3/6 on that?
Where?
3 times
It's
6.
out and out. You're right there.
That?
Yeah.
3 times 1/6.
Okay.
Because you multiply the exponents there. Quick note on simplifying roots. You can combine these. Okay, so this is the same as that. You can still simplify this. And I don't know how you've been taught it. Were you taught with square roots to take out pairs? Oh, do you remember that? Okay, so there's a pair of 7s, that's 7 squared, so you can take it out front, right?
Yeah.
I always give people a second option. This, let's go here, is, if you can break it into, so 14 times 7, I don't know what the number is.
It's,
98? 98 is 49 times 2, right? So if you have the square root of 98, if you can find the perfect square in there, then you can do the same thing. So something such as square root of 32. Is there a perfect square in that as a factor? Which one? Okay, 4, but the biggest one is 16. What's the square root of 16? 4. So when I have the opportunity to use this method, I do because it's faster. But you do have to know your squares pretty well. This always works to break it down into its prime factorization. And you can take out pairs. So take your pick, whatever you want to use. Okay. All right. Alrighty then. Let's see. How would I deal with an exponent that has 5/6?
Make sure the 40 times the down 5.
Okay, that's one option. Okay, so there again, the denominator is the root, right? And now that we see the exponent is the numerator. Okay. Is there another way I can write that? Six root of 46 to the 5th is acceptable as well. Sometimes one of the other is going to be easier for you to use to solve one of these, to simplify or evaluate one of these expressions. Generally, if it's a small number, so I can take one up real quick. No. This is going to be kind of an example you can do differently, but take that for example. This is a small number, correct?
Yeah.
Generally, it's better to do the exponent first. So now this can be broken to 1/2, right? 4 to the 1/2 is 2, right? So you can do this in a different way, but I want to show you what's 4, the 6 root of 4 cubed. Yeah, okay. What's the 6 root of 64? Is 2. 2 to the 6 is 64. So you can see it's a smaller number. Generally better to do the exponent first than the root. Okay. With a larger number, something like this one, it's generally better to root it first. So here I would do exponent first, or small. This is a large number. Just a little strategy, root first. So this is the one where I would do the 4 through to 625. and then cube that. So 5? And 5 cubed is, so just two strategies there in general. Again, those are pretty calculator friendly too. You know how to enter those in a calculator? Yes or no? I can show you.
Okay, you can.
Let me show you. Okay, let's see. Do you know what that means?
Yeah.
That's the root.
Yeah.
And that's the exponent. So root exponent. What's the fourth root of 625? That would be yeah, it's 5. Then you do 5 cubed.
Oh, yeah, I rocked it, and I went by 9, so
So don't forget.
everyone else got it, except the law. Teachers.
Little calculus for you there. Okay, so 625. And then if you do the exponent, the new operating systems bring it up. If you have the black calculators, they probably won't put it in the exponent spot. Just be aware of that. And you're good to go.
Oh my God.
The new operating system is a lot more visually friendly. If you have one of the black calculators, you'll have to put that exponent in parentheses. Okay, so when you press the caret key, it'll open a parentheses. You put 3 divided by 4, and you'll have to close that. Okay, if you close that parentheses, that's when it does the whole thing as an exponent. Is that enough? Good. Okay. I think we're good there. Sometimes things don't work out real nice. Yeah, those are odd numbers with the square root. So sometimes they don't work out really nicely. But I can still pull stuff out. Yeah. Will be. Might be an accidental 2x4 this afternoon.
See, that's something you guys gotta worry about.
So
For you.
Okay, we'll rewrite it as an exponent. Okay, 7 divided by 2 is not a, it's a decimal, right? 3.5. We want to avoid those. So what you need to do is break these into their even and odd counterparts. So this would be r to the 6th and r to the 1st, right? Because that's 7. S to the 24 and S1. We have t squared and t to the 1. Okay. Now I can put this inside here. What's 6 divided by 2? 3, right? 6 times 1/2 is r to the 3.
Let's see.
Can I deal with? See how that's going to work? R to the 6th times 1/2 is r cubed, and it comes outside. You're taking the square root of it. This is r to the 1/2 though. And I split them up for a reason. You'll see why. Okay, what's this become? Yep. And See how these are whole numbers and these are fractions? That's why I'm splitting them up. And that is t
T and then
and t to the 1/2. I can write this as a root if I want to again, right?
Yeah.
So,
oh, so just be R cubed plus 12t root RST.
so you've just, with this is, these are the, you basically did a prime factorization here and pulled these numbers out, because you can. These have to stay in because they're not, you can't take the square root. It's the same thing we did with numbers, we just have variables in there now. Right.
So that's the answer.
Yeah, you're done. Basically, you're getting as much out of a root as possible. That's one of the themes in math. You get everything out of there if you can. Okay. All right, last item. Solving equations. You're pretty good at. Just show you one example and be done. Okay, so what do we deal with the next to the 3/4, right? So subtract 5. There are a couple ways to deal with that. Any ideas? Raise it to the 4th power. That's one option. And that would get rid of the denominator, right? So,
Can't just multiply by 4 first.
yeah, you can actually. So that would give us x equals, so basically all you have to do is split it, take the reciprocal and raise it to that power, and it cancels out. And then, again, with this big number in here, we take the cube root, or sorry, the 4th root versus any bit of the 4th root is 729.
Find out.
Oh, it is the cube root.
Cube root of 729.
9, isn't it? The cube root of 729 is 9. So then we have 9 to the 4th, which is
29 times 9.
63 something. Anybody with a calculator? I don't have that one memorized. We got it right. So deal with those exponents. You can deal with them separately, or you can deal with them all at the same time. Any questions? We're good.
So we can plug in 6 by 6 1 to x is equal to 3.
You don't need to here. Yep, we're good. Okay, do you want me to write the homework up again? Are you good?
Come on. Oh my God. So many problems.
Sure, it says. Okay, the rest of the hours, you got about 15 minutes.
It was maybe through night, right?
Well,
All of them.
Wait, you show us how to get rid of a variable.
Yeah,
What, YouTube?
yeah, I have like.
Oh, we help.
what short case means?
Number 11.
Um, Pretty sure you don't have that in this assignment.
No, we didn't.
We do.
Yeah, number
Number
11.
Number 11, that's not supposed to happen.
Then let's
Okay,
not.
so number 11.
It's mom, so, you know,
At this point, what you're looking at there, I got 2 to the 8n.
It's 2 to the power of 2n plus 3. That's what it says. Your mom, don't know how to got the calculator. That makes sense.
Think, okay, 8n, 8 to the power of n is 2 to the 3n, right? Because 8 is 2 cubed. And then 4 to the negative n is 2 to the negative 2n. Now all your bases are the same. And you can do some adding and subtracting. And you can do the root is to the 1/2 power. So if I ended up with, this is not number 11, but it's very similar. Let's say that's the problem I'm looking at. And those are the same statement, right? This is 4 squared. So now the bases are the same, I can subtract these. Two minus 1. And now if you need to, you can rewrite it as 2 to the 2x, which is 2 to the 2x over 2, which is 3x. That's what you're doing on number 11. I will show you how to, using logarithms, we'll get rid of these 2's. There's an inverse operation for x.
Oh, I'm forgot that part.
You're not alone. Oh,
No, I do.
well, I like you to show you this.